We have got a lot of content for you. So on stage, we have 5 speakers going to talk about a variety of topics. So I will start with Android Wear and some of the things that you may not know about, or some of the top tips as we develop for Android Wear 2.0. Then we are going to have Mark, who will give an update on Android TV. Give us a wave. Woohoo! And then we have Santiago, who's going to give us an update on Exoplayer. And then we have Aga, who will take you behind the scene on our development of Android Wear 2.0 and some of the components that we have built. And last, but definitely not least, we have Dan, who's going to talk about Pro Audio or Android Audio.
Android Audio, yeah.
Android Audio. So get your hashtag ready. Each of our speakers have 6 minutes. Actually, my clock has already started. What's going on? OK, so let's get going. Android Wear. And what I'm going to do is I'm going to talk about 3 things that is little known to developers, and quite often is not immediately obvious when you develop for Android Wear. The first thing is, if your app is standalone, please tell us. So at the start of Android Wear back in 2014, the only way for the watch to connect to the internet is via the phone through Bluetooth. We have subsequently added both Wi-Fi and cellular connection to the watch, but you still needed the phone with Android Wear 1.0. With 2.0, we have added a new way for you to connect, which is via direct HTTP connection. What this means is, if you have connection code that is on your mobile, you could just reuse exactly the same code on your watch. So that's what's been launched with Android Wear 2.0. The advantages of that is, of course, you can run your app even if they're paired to an iPhone, because there's no additional component required on the phone. Another advantage is that users can now directly install your app from the watch itself. We have Play Store on the watch, so that the user can download whatever they want onto their most personalized device. And in order for you to tell us that your app supports this functionality of accessing the internet directly, all you need to do is to put on this metadata tag in your Android Wear app, Android Manifest XML. And after you do that, we will put your app onto the Play Store on the watch. And it will be accessible to both users that is using an Android phone as well as an iPhone. Next, standalone architecture. So many of you have heard about model view controller. So that's pretty much done, right? Standalone architecture, you just put your services in the cloud and all your display logic on the device. Done. Lightning talk. In reality, it's not quite that. So today, the center of gravity for the user is a lot about mobile. You have heard about mobile first. And quite often, we forgot about all the other form factors that the user already have. And it doesn't even need to be another form factor. It could just be the same user with another phone. And this particular pitfall is particularly easy to fall into if you have a user credential that is telephone-based, meaning that when the user log into one device, you lock them out of another. And I see this assumption being built into app again and again. And when they come to extend their app to other form factors, this really hit them, because the user can only log into one device at any one time. So at the very minimum, I would strongly encourage you, even if you are just a startup that is bootstrapping, or you're working on a project over the weekends, build the assumption that the user will have more than one device. So allow multiple security tokens to be active at any one point. You don't need to build kind of cloud-based messaging synchronization. None of that. At the start, maybe when you get your Series C funding, then you could do that. The next thing that we realized when we start building for Android Wear 2.0, which support OAuth login, is that a lot of the time, the user, or the first time the user access your app, could be via the Android Wear device, which means that they may not have an account to sign in. So if you assume that the user can just have this sign-in button for the app, you may be missing out a whole chunk of users. So what we will encourage you to do as you build an OAuth experience is also put in a register button, so that you can enable users that's coming in via other form factors, be it Android Wear, be it Android TV, to actually register for your service the very first time that they're logging in. Last but not least, Android Wear for China. So we are in China, and it is extremely popular. It is our second largest market around the world behind the US. And as you know, many of the Google services are not available in China. And so one of the things that you should do as you use Google Play services on Android Wear is to check that it is available. So there's two ways to do this. One is when you're connecting to the Google Play services, check if the connection failed, that the API is available. And then second, if you have a variety of APIs, let's say 5 of them, and you need it, and if 3 of them connect and you still want them to work, then you could do this and say, add API if available, and then check that the API is actually available before you use it. And there are 3 types of services that is available in China in the Google Play services package. The first one is Google Fit. You can get the 7-day step count from that. Second, Fuse Location Provider. We really, really recommend that you use it if you are trying to get location. It has a lot of battery optimization built in, as well as all the different combinations of way of getting location. So just let us take care of that for you. Last but not least, since Android 1.0, we have the Wear Data Layer. So if you use it, you will need Google Play services. And if you want to compile just once, and against the Google Play services once, for both rest of world and China, then you should compile with the version 10.2.0. And what it enables you to do is for your app to run both within China and also outside of China. So with that, I'll hand over to Mark, who will talk to you about Android TV. Thank you.
Thank you, Hoi. Yeah, let's talk about Android TV. You've maybe already seen the keynote where we announced the new cool features for Android TV coming soon. I'm going to talk about 2 of them. One is the Google Assistant on Android TV, and the other is the new launcher screen, the new home screen, starting with Android O. Google Assistant goes Android TV. That's not really surprising news. We want to have Google Assistant on every surface, on every platform available, so Android TV is just the next logical step. What do you need to do as a developer to make your app integrating with Google Assistant? There are basically 2 ways Google Assistant interacts with your app. First, it needs to find the content your app provides. So it needs a way to query your app for content. This is done by using a search provider. And second, once the content is found, it needs a way to play this content. It needs a way to remote control your app and do playback. For this, it uses the Media Session API. Both of these are kind of well-known technologies. We have these on Android TV since the very first launch a few years ago. So what we see here is the old universal or global search. That's exactly the feature on the former Android TV versions, which uses these search provider as well as the Google Assistant does. Google Assistant now reuses this service and provides a new, more modern-looking user interface, like we see here, the presentation of the results for the query action movies. Now, the user can choose from these movies and start playback. I've already said that these are well-known technologies. There is a lot of documentation available on developerandroid.com. There is a tech guide making TV apps searchable, and there is also a lean-back sample app which provides sample code which you can use and adapt for your app. So now Assistant found the content, or the user found via Assistant the content he wants to watch, and now Assistant uses the Media Session API to start playback. We see here this callback of the media session where the media commands arrive, and you, in your app, just need to delegate these calls to the player you're using. In this case, it's an Exoplayer instance. Media session is as well already well documented. There is a guide on developerandroid.com working with a media session, and there is also a media session extension for Exoplayer, which provides out-in-the-box integration with the media session. So now let's have a look at the new content-first launcher experience, the new home screen of Android TV. We see here this row-based layout. On the top, we see the a row with favorite apps, but then we see these channel rows with programs which an app wants to advertise to the users for recommendation. Each app can at least place one such a channel row on the home screen, and the launcher application takes the data to display this row from a database, from a content provider. So your app needs to insert data into exactly this content provider. Let's have a look how this looks like in code. We have here a sample method which adds such a channel row to the content provider. At the very start, we just create a builder instance, in this case, a channel builder instance, which we then populate with the properties we want to use for our channel. In the next step, we use now this builder to build the content values and insert these content values into our content provider via of the TV contract we are using. In the next step, now we want to add a logo to our channel, so the user can easily recognize to which app a row belongs, a channel row belongs. And we use the store channel logo method here, to which we pass the channel ID and the logo as a bitmap. And now, finally, we want to make this channel visible on the home screen. For this, we request it to make it browsable with the request channel browsable method and pass our channel ID. Now we have such a channel row visible on the home screen, and of course we want to add programs. This works in the very same way, or in a very similar way. Again, we create a builder instance. In this time it's a preview program builder instance, and we populate the data in this builder. Most importantly, the channel ID, of course, with which we link our program to a given channel we've already created. Once we add a title, description, and poster art URI, we now can take the content values again, built by our builder, and insert it into the content provider of the TV contract. This API is already documented in more detail on developerandroid.com. You find a guide about displaying recommendations in the Android TV home screen, which provides you with more details about how you can maintain your channel and program data in the database. With this, a last pointer to our sandbox, Android TV sandbox, where you can play around with the new launcher screen and also the Android TV office hours. We are happy to answer your detailed question about Android TV. And with this, I give over to Santiago from the Exoplayer team.
Thank you very much, Mark. Hello all. Let's talk about Exoplayer. Exoplayer is an application-level media library for Android. It's an alternative to Android's platform media player. And the Exoplayer library has 4 main goals. The first goal is to reduce the effects of fragmentation. Media playback on Android has been flagged to be one of the most affected areas by fragmentation. And Exoplayer moves the majority of the media player implementation to the application layer. And so it's possible to update through regular application updates, hence reducing the effects of fragmentation. Most Exoplayer functionality works from Jelly Bean onwards. That covers the vast majority of Android devices. Our second goal in the list is to provide advanced features. So you already possibly know that Exoplayer provides some features not currently supported by the media player API. This includes Dash, smooth streaming, persistent caching. There are others, but we are also constantly working to add new features. So our latest additions include a set of tools for downloading almost any kind of media and playing it offline. There is also dynamic playlists. So you can create dynamic playlists, modify them on the fly. This functionality is also built in the player, so if we know with enough anticipation what media is coming, we can shorten by a lot the gap between items in the playlist, and you can do very cool stuff with this, like, for example, gapless audio. Which brings me to my next feature, which is there is this new component called buffer audio processors, which allow many interesting audio features, like a playback speed adjustment all the way back from Jelly Bean onwards, and spatial audio for virtual reality. And finally, on a slightly more technical level, there is support for the full Senk standard now. So we have had support for Senk for a long time now. Well, long time. It's been around. And now we have added support for the 3 remaining scheme types. Most interestingly, this includes CVCS, which is the scheme type required by HLS for DRM protected content. So this is interesting for content providers. This is by no way, by no means an exhaustive list, but well, it's a little bit. So there are a ton of use cases for Exoplayer. We know for a fact that no size fits all. So the ability to customize is one of the core principles in Exoplayer. So this is our third goal, to allow customization. So say, for example, that you have amazing content which you want to stream to Android devices, and you come up with a custom DRM scheme. So you create a component, and you inject it into Exoplayer. Then after shipping and having some metrics, you realize you also want to tweak the way you measure bandwidth, because the network conditions of certain users, you want just to tweak it. And by the way, it's also good to customize the adaptation mechanisms. So you create components for that. You inject them to Exoplayer. After shipping, taking new metrics, you realize that you would also customize, you would also like to customize the way you buffer the media. So you also create all these components. All these things you can inject into Exoplayer. There are tons of hotspots for injecting custom components in Exoplayer at very different abstraction levels. And now I'm going to speak about our fourth goal, which is enable easy integration with related libraries. Extensions are Exoplayer modules with external dependencies. For example, the AMA extension. For media distributors who want to monetize their media, this extension, which is a wrapper around the Google's interactive media ads SDK, it makes it extremely easy to play ads along your content. And it's, as a playlist, it's integrated into the player, so you can reduce and almost eliminate the weight caused by buffering mid-rolls during media playback. There's also the cast extension, which is quite new. Apps using Exoplayer can now almost effortlessly cast their content into cast-compatible devices. And you can even use your custom UI components, if you have any, that you were using to control Exoplayer, to control playback on cast-compatible devices. But Chromecast and TV is not all we have in mind. There's also the media session extension, which allows Exoplayer instance to publish a media session. Therefore, you can control that playback session from other apps in other devices. And the images above this being used on a mobile device and Android Auto. So this is very interesting. So Exoplayer can also be used, maybe you know, in virtual reality environments. But the GVR extension also adds support for spatial audio in Exoplayer, which is very cool. It's also possible thanks to audio processors, which I mentioned before. There are many other extensions. Due to time constraints, I'm not going to delve into them, but I just want to mention that most of them, or many of them, can be used to bundle your own software decoders into applications, so you can make sure there is support for specific codecs you're looking for on all devices you want to ship for. So that's all from me. Please check our Medium blogspot. Try out the new stuff, the new extensions, new features. Hope you see you tomorrow at the office hours. Thank you very much. I'll leave you with Aga.
Thank you, Santiago. Today I wanted to spend a little time talking about one of the new APIs that we launched with Android Wear and the support library. And it's got to do with round screens and with lists. So this is our new Wear 2.0 launcher that I started working on around maybe a year and a half ago. And what we wanted to do with this launcher is we wanted it to be fast, we wanted it to be easy to use, but most importantly, we wanted it to fit in with the curved screen that all the new watches have. So round watches are by far the most popular watches at the moment. Users love them, and they are much, much, much more popular than the square ones. So we wanted to adjust our design to that new trend and make it visually more appealing and more fitting with the round UI. So this is how we wanted it to look here on the left-hand side, which is all grand. We knew that, but we needed to figure out how to implement it. So this is what I got from my designers here on this right-hand side, which generally, when you first look at it, looks fabulous. A lot of people forget that the launcher is static. I'm not exactly sure why they forget, but the launcher is not static, I'm sorry. You can scroll it up and down, and once you scroll it up and down, you need to be able to animate those elements in the launcher alongside the curve that we want to achieve. And you don't only want to animate them just like they are, you want to scale them. So you can see the ones here at the top are slightly smaller than the one in the center, which we want to focus on. If it's in the center, that's the focused item. For regular straight lists, a lot of the work is done by Android Framework, but when Android was being designed, nobody exactly thought about round screens, like it's not a thing for phones. So this was a new challenge for us. So when I started looking at the code, you can see on this left-hand side here how the straight list works. It's kind of straight. And when you scroll it, every single element in the list moves by the same amount of pixels at the same time, which creates an illusion of scrolling. It's really a super simple linear function. Now, this is not the case, obviously, with the curved list that we have here. So you can see that not only do we want to translate items on the y-axis, we also, for the curved list, want to translate them on the x-axis. So I'm OK with maths, so I figured a function out for this. You can translate x to y by using a very simple like circle-based function. So I was very pleased with myself. I went back to my design team. I built a prototype. I said, hey, you guys, it's working. It's fine. It's looking well. And they say, Aga, this is really not good. No, this is really, really terrible. We can't launch this. There's no way. It's so bad, Aga, so horrible. No way. What we really want is this. We want the circles to be equidistant from each other, how you see here, which means you can't linearly just translate and have the y position exactly like you would have in the straight list. You not only need to translate in the x direction, you also need to do it in the y direction. So you can see there's a slight slope to these lines here and here. Also, for the eagle-eyed of you here, the slope goes up here, but on the flip side here on the bottom, it goes down. So it just doesn't make it easier at all. Instead of changing just the value of x, we needed to change both the values of x and y. So this is a problem in Android because once you change the x or y values of any view, that triggers a new layout path each time. So if you're changing y in a vertically scrolling list, you will trigger a layout path on and on and on and on and on. Because the new value is treated as an old value in the next pass. And this is obviously not what we wanted. Well, that would completely kind of block the device, so not cool. So instead of changing the value of y, we decided to translate the view by just a little bit. So that is a very subtle difference. Translations in Android do not trigger a layout pass. So this was a subtle solution, and we were pleased with it to implement it in the launcher. But as you can see, this is probably not a unique problem. So we discovered that actually it works for us for the curve, but it could work for any other path. So that's why on the top of this solution for the launcher, my team built an API that enables you to use any chosen path, however funky it might be, right? Like this thing here. I mean, if you want to implement it, you can implement it, basically. I don't know why, but you can. And the only caveat is that we will not give you the maths. We will not do the maths for you. I had enough of maths. So we will give you a container, the wearable recycler view. We will give you all the callbacks, but you need to supply us with the path. And then how the path is used is a little bit like this. So this will go live in Android O when it drops to open source. This is the curve that we use for the launcher. I won't bore you with details. It's basically a Bezier curve with some extra details here and there. So this is the kind of maths that you might want to do. It's not as scary as it looks. It's fine. And then when you have the maths for the path, this is how you would actually use it in code. And this line here is the crucial one, where you just get the tangent line to the path you have and then apply the positions to the children in the view. So here again, this is the general architecture of the API. This is all provided in the Wear UI support library, which is now part of Android support library, which means it's going to get open sourced. And this is the chosen path that you need to provide. What is specifically not provided is the scaling, but that's pretty trivial. We didn't provide it as part of the API because you might want to put in different shapes of children into the wearable recycler view. So to learn more about this API, you can search for wearable recycler view, the curving layout callback, and generally curved layout Android Wear. It's in the developer documentation, and obviously you can just Google it. There's plenty of stuff on Stack Overflow. So that's all for me. I hope this is going to be helpful. And with that, I'll hand over to Dan.
All right. Thank you. That was pretty awesome. All right, let's jump right into audio because we're short on time. So first of all, why a new API? We already have OpenSLES and Java APIs, but we've listened to a lot of developer feedback, and you guys have told us that audio processing with OpenSLES is really hard, and we think we can make it easier to use. And you know, all of these original APIs go through the original Audio Flinger framework, but since making huge changes there could potentially break lots of apps, Audio has a new server, so we can do some pretty radical things that should get us some big performance enhancements. All right. So it uses the concept of streams, and in this case, we can see a stream flowing from the mic all the way back to the app and all the way back to the headphones. And these streams are straightforward to create using a builder design pattern, which allows you to create a builder with your requested customizations that can be then used to create multiple streams. And this is kind of cool. You can actually set up the builder as kind of a rubber stamp to create audio streams. So in this code, we have an audio stream builder. And this gets you a default stream, which is probably a stereo audio output stream. And here's how you would request specific values for direction and format. So you can see you can get input and output streams from this. And once you set up the stream, you can call OpenStream on the builder. And if you didn't set things like the sample rate and format, you'll need to query them. And finally, you'll get the frames per burst from the audio stream to get the optimal read-write size. And this is kind of how this all works. You know, in audio, a buffer refers to these arrays of these bursts. And this data is written in these bursts to the DAC, which actually turns audio into something your headphones can actually hear. Yeah. And in this diagram, this app has generated 2 bursts of data, and the first burst will be written. And as you might expect, you can start and pause and flush or stop your stream, all with asynchronous calls. And for most use cases, this is optimal. But we do have functions that you can synchronize these things if you need to. All right. Again, this is a simple API. We've got to cover it in 6 minutes. So how did we get data in and out of the streams? OK, so for apps that don't need super low latency latency, you can just use blocking writes. And here we're in a loop, and the blocking write function returns either the number of frames written or an error. And this blocking write can time out, so we might only get part of the frames written. So we need to make sure to handle that case. OK. But when you need the lowest latency, you need to be running on a special thread to do your audio processing on. Maybe one that's scheduled with sched FIFO. So you write this callback function, and audio will pass you the stream parameter, any user data that you need, the audio data buffer, and the number of frames, and then you can render your audio right into that audio buffer on the high priority thread. So you set up this callback actually in the builder. All right. So then people are like, well, what I really want to do is do audio processing. That means I need to take audio that comes in and turn it into something. So how do I do that? How can I mix 2 or more input streams and send it to an output? So what you do, we recommend, is using a stream as the master callback, usually the output stream. And in this simple example, we're just passing data from input to output. Oh, I love my square there. And we read from the input stream with a 0 timeout to do a non-blocking read. And that goes right into the output buffer. And notice that it may take a couple of calls for these 2 streams to synchronize. Ta-da, output stream, input stream. OK, finally, let's talk about dynamic latency tuning. And this is kind of important. Because looking back at our previous diagram, we have 2 bursts ready to be consumed by the DAC. And if we're glitching because we're getting preempted all the time, we might want to add another burst to our renderer. And so this is kind of the way we do this simplified. We can detect overruns or underruns we've had on our output stream by calling getXRunCount. And if it's changed since the last time you checked, you've got a glitch. So you can just add another burst to your buffer size. Pretty straightforward. So once again, here is basic A-audio using a blocking write. Okay, really simple. We've got a stream builder. We open a stream. Pretty straightforward. We request start. And then while we're processing, we just write frames. Like, kind of how audio should work, right? OK? And then we close it when we're done, because we're always good. And this is a C API, so we really need to make sure we close things. And here is just a partial equivalent of what we'd have to do this in OpenSLAS. So again, the goal is not just only make audio higher performance, but it also gives us, it makes it much easier to write these programs entirely. And so now you're saying, like, but wait, like this is only an Android O. Like, well, how am I going to use this? And so the good news we have for that is that we're actually working on a C++ wrapper. And this wrapper is not only going to be able to target Android O and A-audio, but it's actually going to work on older Android platforms as well. And so you'll actually be able to use this new simplified interface, in fact, in some ways almost easier because it's C++, on both older and newer versions of Android. So pretty cool. It's going to have similar concepts. It's going to use DLSIM. It's going to use DLSIM runtime linking to talk to A-audio, or it's going to have a back end that talks to OpenSLAS. So cool, and that's it. We've covered it in 4 minutes. It's that easy. And it really is. Like honestly, the audio developers we've worked with who've used this API already have come back and said, "Thank you." And if you, how many people here have actually tried using OpenSLAS to do their audio app? See, that's how popular it is. Anyway, so on behalf of myself and all of the presenters who come to the stage to do lightning talks, thank you all for coming. And we're going to have office hours. So today you can come to Android Wear office hours. We're going to have Android Auto office hours tomorrow and Exoplayer office hours. So if you have any burning questions you've had on any of these topics, please come by and talk to us. You can also, if you see me out there, I can try to answer questions on Android on A-audio, which is also pretty cool. And that's it. So thank you on behalf of the panel.